Let's move on to part B of question 2. The boy now starts to walk slowly along the beam towards the end A. So the boy is moving towards the left, towards A, okay? Find the greatest distance he can walk from P without the beam tilting. Now the method that we use to solve this kind of a question is that basically we know that the boy is moving towards the left or towards A, therefore the beam will tilt upwards from B. And when it starts to tilt upwards from B, the reaction at D will become 0 at some point. And then as soon as it becomes 0, after that it will lose contact with that support D and there will be no reaction at all. So the final point that the boy can reach without it tilting, at that point the reaction at D will be 0. So this is basically the main thing that we consider in solving a question like this one, okay? So let me just come here, and when the beam, or basically before, let me just say right before the beam tilts, our D will be 0. We will be solving this again using moments, and I'm going to be taking moments about C, so I need to know the distance of P from P to C, which I don't know, so I'm going to label that as X. So I'm just going to say that let CP or PC equal X meters. And keep in mind that the answer that we get for X will not be the final answer, because that will be the answer, the distance of P from C. It will not be the distance that P has traveled from its original position. So we will have to do a few subtractions, etc., to find the final answer which they're asking, okay? Now, what I'm going to do is write down that taking moments about C. I have 20g multiplied by the distance 0.4, 20g times 0.4 meters plus 60g times x. Now there's another problem here, that we don't know if the boy will be somewhere here. If the boy will be somewhere around here, or if the boy will go beyond C and he will be here. So we don't really know that, but the sign of our final answer will actually help us know where the boy actually is, because what I'm actually trying to say is that if the boy travels, let's say, a certain distance here and stops here, let's say at this point, right? So the distance traveled would be the initial distance of P from C, which is 1.4, minus the new distance, and it'll give us the answer. But if the boy is here beyond C, then we will have to add it. So 1.4 plus the extra distance after C, and that will be the distance traveled by P. So that confusion, you don't have to worry about it now and keep thinking that, oh my god, how do I know, and how do I know if it'll be clockwise or anti-clockwise? Because if P is here in the final answer, P is here when the beam is tilting, then it's anti-clockwise. But if P is here, for what I'm pointing here, so if P is here after the beam starts to tilt, then it will be anti-clockwise. So my answer could be wrong. You don't have to worry about that for now. I'm just taking it as on the right of C, okay? So I'm taking it as at this point. Let me change the color to make it clear. So what I'm taking is, I'm taking this at this point. And as you solve, everything will become clear. Okay, equals, here we have 0. Why am I writing this? You don't really need to write it, but it's good to show that. So the reaction, because we have taken the reaction here, and if we show that how we're solving this question, it might be important to get that 1 mark. So because the reaction RD is 0 and the distance from C is 2, so 0 multiplied by 2. This would be 0, okay? So 20 times 0.4 would be 8g plus 60gx equals 0. Now I will subtract 8g from both sides, so I'll have 60g x equals negative 8g, and then dividing by 60g on both sides, I'll have x equals negative 8 over 60, and then we have g's which cancel. So the final answer is this is not the final answer. What I mean is the value of x is negative 2 over 15 meters. So the negative tells us that it basically was actually here. So even if we did not know that before we started solving the question, now looking at this negative sign, we know that it's on the left of C. But you don't, now what you could do is, to find the distance P has traveled, you could either do 1.4 plus 2/15 directly, or what you could do is, for example, let me just show that because that's more confusing, so I'm going to write it down. So we can say that the distance traveled by P is the initial distance of P from C minus the current distance that P is at from C. So the initial distance minus the current distance. So it would be 1.4 minus, now what's the distance right now? As we found out here, it's negative 2/15. So negative 2/15. So you see what I did there? If you write it like this, even then you will have 1.4 plus 2/15. Or if you look at the sign here and change your diagram, or basically you find out early that okay, P is here, you can directly use just the magnitude of x. And if you're still confused, you don't have to look at the diagram, or you're maybe not drawing the diagram, you can directly use this value as it is with the sign, and you will get the correct answer either way. So 1.4 plus 2/15 gives me 23 over 15, which I can write to three significant figures as 1.53 meters. Now this part was a bit confusing in terms of explanation. I don't know if I explained it clearly or not, but I hope I did. And if you have any doubts, you can ask me down in the comments, okay? Let me just summarize this a little bit more for the people who did not understand, and let me just show you what I basically did. So here what I did was that P is moving towards C, okay? And when it's moving towards C, a point will come when the reaction at D will become 0, and soon after that, when P moves a little bit more towards A, basically, this reaction there will be no reaction here at all, because then the contact will be lost between the beam and the support D. So there will be no contact at this point. Okay, we are taking the point when it becomes 0, at that exact point. At that exact point, now before that we have to mention the distance of P from C. We take it as x meters. Then we take the moments about C. When we take the moments, we find out that x is actually negative 2/15. We initially assumed that P was here on the right of C, but the sign actually tells us that no, it was actually to the left of C. So here you could either use the exact value of x and go with your initial plan that you had, because according to your initial plan it was here, and you were supposed to subtract the value of x from 1.4, and when you will take the exact value you'll get 1.53. Or you could change your initial plan, and now because you know that it's towards the left on the left of C, you can simply take the magnitude of x and add it to 1.4. Okay, I hope it's clear, and thank you for watching.